If you've been watching out for the space news recently, you may have noticed that the moon's under attack. Well, at least it seems that something's going to hit the moon today, if you're watching on March 4th, 2022. But what's actually about to hit the moon? And why is that important in the first place? So what's actually happening at the moon is that a second stage of a rocket is going to impact sometime today. Whose second stage is it? Well, we don't really know. It could be a SpaceX second stage. It could be a Chinese Long March second stage. There are some debates that have been going on online about whose responsibility it is, but ultimately it's going to hit today regardless of whose it is anyway. So does it really matter that a relic of our past is going to impact the moon sometime today? Well, to answer this question, we have to delve a little deeper into the topic of space junk, because that's ultimately what this piece that's going to hit the moon actually is. So what is space junk? Space junk is pretty much anything that is in orbit which is not actually having a particular function or actually doing something right now. Well, the first type of space junk is just satellites that are no longer being used. So after we've launched the satellite into orbit and it's done its thing for a little while, eventually the satellite will run out of fuel, or something will go wrong with the satellite that causes it to no longer work. So what happens to the satellite now? In a lot of the older models of satellites, that was basically it. The satellite would just continue on orbiting, just now no longer functional. The problem with this is that if there's ever a chance of a collision, or potentially that satellite coming to the path of another satellite, it no longer has the ability to move out of the way. So essentially, it's just a piece of junk floating through space. Another common type of space junk that is often orbiting around the Earth is actually from the rockets that we use to get things into orbit. The second stage of the rocket that actually ends up injecting a satellite into orbit is also, at the end of its mission, actually also in orbit. So what happens to that big rocket that got the satellite into orbit? Where does it go? Well, in the past, this was also a problem because many rockets just left those things in orbit. The problem with this is that now you have another piece that is not controllable and is potentially clogging up major orbits where there are lots of satellites. After all, the rocket is what got the satellites there in the first place. This is the exact type of space junk that's actually going to impact the moon today. Although the second stage was not specifically targeting the moon, things like orbital perturbations caused by the moon's gravity and other types of factors can change the orbit and eventually cause something like this to happen. But ultimately, this isn't the most dangerous type of space junk for humans. The ones that are of most concern are the little tiny pieces of space junk. The last formation method for space junk is actually just when satellites and other pieces might collide, or also when haphazard astronauts might accidentally drop something into orbit, like a nut or a bolt. Or in one case, there was actually an astronaut that actually accidentally left his whole toolbox in orbit. Talk about forgetting your toolkit, my goodness. So we have all these different types of space junk. But is it actually dangerous? The main threat that space junk poses is that it could be a threat to things that are actually in orbit and working today. If there were to be a collision between a piece of space junk and an operating satellite, that would definitely destroy the mission of the satellite, and if it was a space station or a space vehicle, it could actually be a threat to human life. For the big pieces of space junk, this usually isn't too much of a problem because we usually have really good advance warning as to whether the space junk will pose a problem to the satellite or to the spacecraft. Current radar technology can usually find pieces of space junk all the way down to the size of about 5 centimeters squared. So it's pretty good at detecting space junk before it can actually become a problem. In these cases, spacecraft and satellites can maneuver out of the way of the spacecraft, usually days or even weeks in advance of when a projected collision could happen. Spacecraft and satellites also have ways of dealing with some of the smaller types of space junk. Space junk that is smaller than about 1 micrometer across can be stopped with technology like Whipple shielding. This is basically just 2 sheets of metal that are placed with a space between them that will be put onto the spacecraft. And when a small piece of space junk impacts with that shield, it'll vaporize the first sheet, and that vaporization event will cause the space junk to be completely pulverized and vaporized, and that will be blocked by the second sheet. This is a special type of shield that was designed specifically to deal with these types of high velocity impacts. But if you haven't noticed, there's actually a bit of a gap between the small types of space junk and the big types of space junk where there could be a real danger zone, and that's from about 1 micrometer in diameter to about 5 centimeters in diameter. But maybe you're thinking like, like that's pretty small. How could such a small thing destroy something as big as a spacecraft? Well, the problem is actually the velocity, not so much the mass and the size. Hitting a piece of space junk in orbit just 1 centimeter diameter would have the same impact energy as if the whole spacecraft was hit by a car on the highway going 100 kilometers an hour. Spacecraft are usually designed with pretty thin walls because you want to be as light as possible in order to get to space. So having that kind of impact energy is really not what the ship is designed to handle. So something as small as just a nut can really destroy an entire spacecraft. And if that were to happen on the International Space Station, that would pretty much be the end of the space station. So considering the danger of impacting objects of this size, what's the probability that this could actually be a problem? It turns out there may be over hundreds of thousands of objects in this size range that are orbiting Earth today. So wow, that's a lot. Like, that seems a little bit scary. But remember, space is still pretty big, so the chances of hitting an object this small is still pretty low. It's kind of like the lottery. If you win, you really win big. Except maybe it's more of a negative winning. So the question is space junk really a problem? Well, in certain orbits it can be quite dangerous, but there are some natural mechanisms that help to lower the risk that we will have these types of impacts. Most of the space junk that humans have created is actually in low Earth orbit, which just means that the orbit is lower than about 500 kilometers in altitude. This is where we launch most of our satellites, so it makes sense that this is where most of our junk would be. However, at these orbital altitudes, we're not really out of Earth's atmosphere yet. There's still a little bit of gas that is floating up there at these altitudes that slowly slows down anything that we put at these altitudes. For example, if there is space junk that's created, usually it comes down relatively quickly. One of the other useful orbits that we often use is called a geostationary orbit. And this just means that the satellite rotates around the Earth at the same rate that the Earth rotates itself. So it makes the effect that the satellite kind of hovers in the air, or hovers in the sky in the same spot. However, these geostationary orbits are much further away from the Earth, like on the order of about 40,000 kilometers away, which means that there isn't much of Earth's atmosphere to interact with the satellites that are up there. So if you put them up there, they essentially stay there forever. This means that as we put more and more satellites into this orbit, it's getting more and more clogged, and of course when those satellites are dead or not being used anymore, they become space junk, right? Well, that's not entirely true because we have really special rules about how to deal with this orbit, specifically for this reason. Your satellite needs to have enough fuel in order to boost itself into what we call a graveyard orbit, which is an orbit that's just beyond the geostationary orbit, but will not interfere with any of satellites that are actually operating in that orbit. So in a way, this doesn't actually solve the problem of space junk, it just moves the space junk to where it's not going to be a problem for humans. Graveyard orbits are essentially the trash heaps of the solar system. The really big problem for space junk is actually in what's called a polar orbit. So these orbits are important because satellites there are going north to south. And they all come north to south in different orientations around the Earth. And so basically what happens is that the poles, they all kind of cross over the same point. And obviously this gets a little bit dangerous because coordinating when each satellite crosses over to make sure there's no collisions can be a bit difficult. And it's especially difficult when you have some satellites that are just junk and don't have any control. If there were to be a collision, this would obviously create a lot more space junk, which would make the probability for collisions to go higher. And then you would have more collisions and then more collisions, and essentially you just have a big, huge trash heap eventually all around the Earth. This is what space engineers call Kessler Syndrome. As we put more and more satellites into these types of orbits, we're actually increasing the chances that we could initiate a Kessler Syndrome type of event. But hopefully that's not for a little while longer. So, how does this relate back to the original story, which is this second stage rocket engine that's going to impact the moon sometime today? Well, it's actually kind of a good thing that the second stage will impact the moon because it actually removes it from the debris that's floating around the Earth right now and could potentially cause another impact, making more debris. And I mean, it's not like the moon is occupied right now. There are 0 humans currently living on the moon, so there's really no risk to human life if the second stage falls onto the moon. Yeah, maybe if there's some moon aliens, maybe they might be concerned about having a piece of a rocket falling from the sky. But to be completely honest, if you look at the impacts of the moon goes through just on a normal basis because of asteroids and stuff, this is like a drop in the bucket because literally thousands of things hit the moon in the course of a year and not a lot of them are human-made. Yeah, so in the end it's kind of a bit of a media circus with this whole event. I mean, it doesn't really mean that much that it's impacting the moon, and does it really matter whose piece of rocket debris it is? Not really. But it does shine some light on the problem of orbital debris, which is maybe kind of a good thing, because it's definitely something we need to think about more in the future if we want to make sure that we have presence in space. Yeah, Kessler Syndrome is really bad. We definitely want to avoid that 100%. If you like this content, be sure to help out the algorithm and drop a like on the video. And remember to keep expanding your horizons.
I want to be the best in the game, invest in my name, check no restraints, I'm obsessed with the pain, I ingest, I retain, assess and I change, possessed by the thought I'll be free one day from society's restraints, money, clout and fame, mud, disease, a plague, we all love to hate, have to play the game, have to make a name, all our insecurities are...
Hitting a piece of space junk in orbit just 1 centimeter diameter has the same impact energy is as if... Why can't I say this? If you lose, you really lose big. No more spacecraft.